Okay, so we're still in section 9.3, law of sines. We're going to explore another risky case, the side-side angle case. So in this in this example, we're given an angle of A at 40 degrees, a side length A at 13 inches, and a side length B at 16 inches. So the question starts with draw two possible triangles and solve them. This is not how the questions are going to be phrased in the textbook or on an assessment. It'll just give you the information for the triangle and say solve it. And you're expected to know if the information provided leads to exactly one triangle, exactly two triangles, or no triangles. So there's if there are two possible cases, then one of the angles you have in the triangle would be acute that you're finding, and then the other one from the law of sines would be the obtuse angle. So there's the acute scenario and the obtuse scenario, and this is a side angle scenario, right? So first we'll work with the acute case and we'll set up our triangle and label it. Okay, so I have my triangle labeled. Again, you can see we're in the angle side scenario. So this is definitely risky, meaning there might be two triangles possible or no triangles possible. But to start, we have to start with the law of sines. And to use the law of sines, you need an angle and an opposite side length. So we're going to start, right? So I'll take sine of 40 degrees over 13 units equals sine of angle B over 16 units. There's no other way to start with this problem because we don't have an angle for C or a side length for C. So we have to start with looking for angle B. And we're going to solve this just like we did in the previous examples where we are going to, in this case, cross multiply. Actually, we don't need to cross multiply in this case. We can just multiply both sides by 16 to remove the denominator from the right fraction, leaving us with 16 sine 40 over 13 equals the sine of B. Now, this is a positive value, which means the angle B we're trying to identify exists in quadrant 1 and quadrant 2 from solving trig equations, right? So we'll first start with the value that the calculator gives us, which will be the acute angle. So we take the inverse sine of both sides. This is our exact angle measure for angle B right now. The approximated one to the nearest hundredth is 52.29 degrees. So this is angle B, right? So let's go up to our triangle and label angle B. And now we know we have two angles. So we can find this third angle easily with the triangle sum theorem. All three angles always sum to 180 degrees. So in doing that, we end up with angle C is approximately 87.7 degrees. So let's go back up and label that as well. At this point, we're going to continue to solve this triangle, right? So we just need to find side length C. Again, we're going to use the law of sines to continue here. So sine 40 over 13 equals sine 87.7 over side length C here. So in this case, we do have to cross multiply. So we'll take care of that step, and then we're solving for angle C. So we're going to divide sine 40 off of both sides here, leaving us with an exact value of 13 sine 87.7 degrees divided by sine of 40 degrees. And this is in inches, approximately 20.21 inches. So I'm going to label my information over here on the right. So angle B is here, angle C, and then side length C here. Okay. Now, don't forget about the second potential case. We still need to verify if we even have a second case at this point. So what we're going to do is we're going to take the information given, the original 40-degree angle, 16-degree side length, 13-degree side length, and label a second triangle. Now, when I do this, I'm going to sketch a triangle a little differently than this because we're going to move to the obtuse angle case instead of the acute angle case, which means angle B here is potentially going to be an obtuse angle. So let's jump over to the next slide here. So same information again, still side angle. It's still risky. So I sketched the same triangle, except instead of making angle B appear to be acute, I made it more of an obtuse angle for visual purposes. We still have to start the problem the exact same way we did in the previous problem. So a portion of your work is already completed. We're going to use the law of sines to find angle B here. That's the only way to move forward, right? So you can use a lot of that work from the the previous example. So that's giving us angle B is 52.29 degrees. Now this is your quadrant 1 angle, right? But remember, when you go to solve a trig equation and you take the inverse sine of both sides, there are two potential angle measures, one in the first quadrant and one in the second quadrant. So to find that second quadrant angle, we're just going to, I don't know why it's not popping up for me. We're going to subtract that given angle, or the angle B, from 180 degrees, and that's going to give us 127.71 degrees. This is our scenario 2 angle B, right? So I'm marking it as B prime because it's technically from a different triangle, 127.71 degrees. So this is our obtuse angle case. So now I'm going to take the information I have and add it to my existing triangle, right? So angle B is 127.71 degrees, right? So what's nice about this is we can continue to use the triangle sum theorem to find angle C prime for this specific triangle, right? So if I add the two angles together, subtract from 180, I can find angle C, which is going to be 12.29 degrees right here. At this point, we're going to continue working with the law of sines. We have one more step to find side length C prime for this triangle. And we're going to start the same way. So it's going to be the sine of 40 over 13 equals sine of 12.29 over side length C prime. And in this case, again, we kind of have to cross multiply, just like we did in the last one. We're going to isolate C prime here. So we're going to divide both sides by sine 40 degrees. This is my exact side length in inches for C prime. The approximate version would be 4.30 rounded to the hundredths place. And this is in inches. Don't forget to include your units of measure because now you're finding angles and side lengths with different units. So this would be the ambiguous case where you were given a side-side angle scenario where there were two possible triangles and we had to identify all angles and side lengths for both of those triangles.